Here's another example of a radical function, in particular a square root function. We have n equals the square root of w plus 6, w plus 6 being underneath the radical sign. Let's ask and look for the three items here: domain, the vertical intercept, and the horizontal intercept. Now, the domain here, we have to try to understand and think, what are the possible input values here of our input variable, which is w for us. We have to think in a logical form, what are the values that make w plus x bigger than or equal to 0. Why do you say bigger than or equal to 0? Well, if you remember, you can't have the square root of a negative number. You could have the square root of 0, you could have the square root of a positive number, you just can't have what's underneath negative. So we're concerned with the w values that make w plus 6 negative, and then exclude those. So we can do that in real easy, what I call the double star move here, is let's find out what makes w plus 6 bigger than or equal to 0, the non-negative numbers. And we can do that real simply by solving this inequality. So w is greater than or equal to negative 6. So those are our input values that would yield a real number. So our domain here is all real numbers greater than or equal to negative 6. So you could write that out or simply use this notation. So there's our domain. W is bigger than or equal to negative 6. Now on our graph, we expect our graph to look something like this. If this was negative 2, 4, 6. So our graph would start here at negative 6 and then have some picture this way, but not this way. All right, let's go after the vertical intercept. Well, let's take a look at the graph first. So we have the square root of x plus 6. Let's take a look at the graph on a standard window. Notice what my graph starts at. It looks like at negative 6, and in fact it does. So my graph starts here and goes up. All right, so let's go after the vertical intercepts, where the graph crosses our vertical axis right there. That occurs when the input variable is 0. For us, that means when w is 0. And so 0 comma something are the coordinates of that point. Let's go after that something. So we'll place w with 0. And real easy here, we have that output variable, or the corresponding output value to that input is the square root of negative 6. So we could write it that way, or if I ask you to approximate with a decimal, you can find that in your calculator. So 0 comma the square root of 6 is the coordinates of that point right there. Let's go after the horizontal asymptote. Well, not the asymptote, intercept. It's the coordinates of that point right there where the graph crosses our horizontal axis. Well, that takes a little bit more work here. The idea is that this coordinate has an output value of 0. So we're interested in finding the input. So the output here is 0. We're interested now, what are the input value that gets me that point? Well, the idea here is to replace your output variable with 0. So you'd have 0 equals w plus 6, or the square root of w plus 6. And now we need to solve this for w. I'll show you in class how this works, but maybe you'll watch this after and be reminded of this. To get rid of this square root, we can square both sides. So that when you left side, you take the square, or when you square 0, you get 0. When you square this square root, that squaring undoes the square root, and you really have w plus 6. So that w equals negative 6. Now if you can't see that, I'll help you. So we get w equals negative 6. And so our horizontal intercept is negative 6 comma 0. So that's the coordinates of that point.